You should like today's lesson because, quite honestly, there's nothing new. Instead, we're just going to take a few moments and notice some perfect patterns. I may have actually renamed this perfect patterns. They're special because they're perfect. Nice thing about special perfect patterns is that they end up having uh, some special shortcuts that allow us to make some quick work of that factoring. Now, remember, factoring is when you're doing a problem backwards, but sometimes it's helpful to do the problem forwards. That is, to multiply the problem so that we can maybe think about how we can reverse that process. So here we have x minus 3 squared. And, well, if you're saying that you know how to do this, good, but I still want to remind you that you don't do this. Uh-oh, were you thinking of distributing the square? Yeah, that's not a good idea. That's actually a math teacher's nightmare. Instead, you want to interpret the square as simply x minus 3 times x minus 3. You want to interpret that as a multiplication problem, because then we can actually do this multiplication. Some people call it the distributive property. Some people call it the FOIL method. Whatever you call it doesn't matter, but get my act together here. Let's multiply x times x and get x squared, and multiply x times negative 3 to get negative 3x. Well, you continue to distribute or multiply or do the FOIL method, and you take negative 3 to get negative 3x, and then plus 9. I know, we've done this problem before, but there's something special about it. There's something special about the type of final answer that we get when you combine your negative 3x's as well as record your entire x squared minus 6x plus 9. Let's look at another one, though. Might make it a little bit easier before we get ready to recognize the pattern. 2x minus 7 squared, right? 2x minus 7 times 2x minus 7. Once again, distributive property, FOIL method, whatever you like to call it. But you're going to distribute or multiply 2x onto both of those. And then you're going to multiply negative 7 onto both of those. So we have 4x squared minus 14x minus another 14x. Looking a little special, right? We end up with those two negative 14x's being negative 28x. Don't forget about your plus 49 at the end and your 4x squared at the beginning. Now here's the thing. Do we realize that you can take this answer and you can turn it back into these factors? Well, you will notice that once you realize that 4x squared was perfect, 49 was perfect. Both of them came from interesting numbers. They came from 2x and 7. And you see how 2x and 7 can help us to end up with 28. In this problem, technically negative 28. Same thing over here. X squared minus 6x plus 9 can turn back into these factors. That's because it's perfect. In a way, the x squared, it came from an x. The 9, it came from a 3. And you see how 3 and x can help us to eventually arrive at this negative 6x. Well, in a moment, we're going to talk about that pattern. But let's look at two other problems. Kind of nice to just do all these problems. Do you notice that this is different? That would be helpful. Do you notice that this is 2x plus 7 than 2x minus 7? Yeah, there's a plus and a minus. Now, when you have a plus and a minus, then one of your terms ends up being the opposite. That is, these 14x's end up being the opposite. And, sorry about that, I made a mistake. 2x times 2x, that's 4x squared. 4x squared. I was so concerned about these negative 14x's being opposites that are going to cancel out. And we end up with just 4x squared minus 49. Now 4x squared minus 49 is also perfect, and it can turn back into these factors. So is it going to work here? It should work. Okay, we're going to end up with an x squared. We're going to end up with a minus 4x. We're going to end up with a plus 4x and a minus 16. Are you already ready just to cancel these 4x's and just write x squared minus 16? That's because this is a perfect pattern. This came from an x. This came from a 4. All we have to do is realize how to turn them back into these factors. And we'll do that by looking down here at our two rules, our two special rules for today.